So hi everyone. Today we have another problem, that is modular exponential for a large numbers. So you are given t numbers, that is x, n and m. You have to perform x to the power n mod m. So that's the question that they states, and obviously the number of x, n and m that will lie between 1 to 10 to the power 9. That is huge. Obviously, you cannot calculate that much of number of powers. It will not possible. So that's why they have given mod. And using mod, we have a limited number of digits that we can store into our long int. So basically, the question is reduced to x to the power n. Mod is not a big deal here. So how can we calculate that much of numbers? And obviously the time complexity they are asking for, that is log n. So how can we deal with this question? Let us have a small example, that is 2 to the power 13. Okay. So one thing is sure, that if we generally calculate for all the values of 2, basically 2 into 2 into dot, and 2, that will be number of 13, basically 1, 2 and 13, then it will take uh, linear time complexity, right? So we cannot afford that. So one thing is sure, that if you are telling, if you are provided the time complexity that is log n, then it is somehow reduced to divide and conquer approach. How? Because divide and conquer approach, basically what does in the divide conquer approach, we divide in the middle and then we work for the left hand side or right hand side, and then we have to break it into the middle position, right? And it will reduce to log base to n. Okay. So one thing is sure, that we have to somehow implement divide and conquer approach here. So how can I use this approach? Basically, if you carefully see that this number of 13, you can write this like 1 and 6 and 6. Means, to make this number, you may have the 6, 2 and 6, 2 and 1, 2. And that will, if we multiply these three things, then we will get the answer, right? So why I am taking this thing single one? Because we cannot divide 13 equally. So if we divide it equally, then if you have one 6, another one 6, and another one 1. So basically, if we calculate 2 to the power 1, 2 to the power 6, and 2 to the power 6, then you can have this answer. Okay. So now this is the time to break this 6 also. It can be broken into two trees, right? Obviously. And here you can see that you cannot break it evenly because it is an odd number. So you have to keep another one here. Okay, so let us write here, that is another one, and you can break it like this. So this will be the divide and conquer approach. Now if we calculate all the values of this single unit, that will be 2 to the power 1, 2 to the power 1. Here is also 2 to the power 1. It will make 2 to the power 3, that is matching, right? And here also we have 2 to the power 3, that will make 2 to the power 6. Yes, it is also matching. And we have 2 to the power 1 here and 2 to the power 6 here. So now if we multiply all the values, then we have 2 to the power 13. So this is how we can break this solution to have log n time complexity. So let us try to write the code. So let us declare our answer variable, that will be long int answer, that will be equal to 1, and let us keep our integer x into our limit. How can we do that? Basically, int x, sorry, x will be x mod m. Okay, so we will run a while loop, and that will be until the n is bigger than 0, then we have to continue. Why? Because you can clearly see that this is the base case and we cannot move further. So until and unless the value of value of n is 1, we have to continue this approach. So if n is odd, mod 2 is equal to 1, if n is odd, so we have to add a single instance of the number. So it will be answer is equal to answer into, that is x, and we have to mod it again, that is this one. Okay, now we are taking one single instance, right? And now, so let us take another example, that is 13, and we are taking one here. Now it will remain 12, right? So we have to divide it equally. So suppose you are having x to the power 3. Okay, let us take another. Okay, this is okay. So we have x to the power 4, and we have to divide it equally. So how can I? X into x, that will be to the power 2 power 2. So this is correct. So we have to do this thing. Basically, x equal to x into x, and obviously you have to use mod here also. That is m, and we are dividing. So the number of n will be n is equal to n divided by 2. So this is the approach, and basically when the number of n is 1, we are including the answer into answer variable. Let us return answer, and hopefully everything is correct. Let us try to submit the code. So it is working fine. Let us take a bigger example. So okay, this is also working fine. Let us share a trick with you. Basically, when you see this kind of things, like you are given x or n and you have to mod something, always you try for the upper bound of the constant. If this pass, then all the test case will be passed. So I'm not going into this example because it will be large enough. So it will work fine, I guess. Just try to submit the code. Okay, so it is running, and time complexity that we are using, that is log n, and space complexity is O of 1. And if you are using recursion, then you will be needed a auxiliary stack that will be something log n also. So yeah, this is the approach to solve this question. And thank you for watching. See you in the next video.